Let H and K be subspaces of a vector space V. And we want to let H plus K be defined as the set of all vectors W, such that vector W is equal to the sum of vector U and vector V, where vector W is an element of subspace H, and vector V is an element of subspace K. And our job here is to show that H plus K is also a subspace of vector V. So to get us started, let's let H and K be subspaces of vector space V. And we want to show here that the sum of these two subspaces is also a subspace of V. So we want to keep the conditions or the properties of a subspace in mind as we proceed. So the first thing that we need to do is show that the 0 vector is an element of the space H plus K. And so since we know that H and K are subspaces, we know right off the bat that the 0 vector is in H and the 0 vector is in K. So if we define vector W as the sum of vectors, the 0 vector plus the 0 vector, this gives us the 0 vector, which is thus in set H plus K. So we have shown that the 0 vector exists in this set. We now want to go ahead and show that the sum of the subspace H plus subspace K is closed under addition. And so as we proceed here, let's keep in mind what we need to show. So for all vectors W sub 1 and W sub 2 that exist in H plus K, we want to show that the sum of these two vectors, so W sub 1 plus W sub 2, is also in the set H plus K. So let's begin by defining W sub 1 and W sub 2. So we want to let vector W sub 1 and vector W sub 2 be in the set H plus K, and this is such that vector W sub 1 is equal to vector U sub 1 plus vector V sub 1, and vector W sub 2 is equal to vector U sub 2 plus vector V sub 2. And we'll give ourselves more room here. So then taking the sum, we have vector W sub 1 plus vector W sub 2 is equal to vector U sub 1 plus vector V sub 1 plus vector W sub 2 plus vector V sub 2. And we can group up our like terms here. We'll group the U's together and we'll group our V's together. So this is equal to vector U sub 1 plus vector U sub 2 plus vector V sub 1 plus vector V sub 2. And we can make a note here, since H and K are subspaces on their own, so since H and K are subspaces, this tells us that the sum of vector U sub 1 and U sub 2 is in H, and the sum of vector V sub 1 plus V sub 2 is in K. So therefore, we can conclude that vector W sub 1 plus W sub 2, which is defined as vector U sub 1 plus U sub 2 plus vector V sub 1 plus vector V sub 2, is an element of the set H plus K. which is what we wanted to show. And so we have confirmed here that H plus K is closed under addition. We have one more to go. We now want to show that H plus K is also closed under scalar multiplication. Oop, not 2, 3. Show that this set H plus K is closed under scalar multiplication. And again, just to guide us as we go, what is it that we want to show here? We want to show that for all vector W sub 1 in H plus K, and for all scalars C, we want to show that this scalar multiple C times vector U sub 1 is also in the set H plus K. So starting similarly to property number 2, let's let vector U sub 1 be an element of the set H plus K such that vector W sub 1 is equal to vector U sub 1 plus vector V sub 1, where vector U sub 1 is in H and vector V sub 1 is in K. And we also want to go ahead and let C be any scalar. Again, we're restricting ourselves here to the reals. And so we're ready now. We want to take the product. So I have scalar C multiplied by vector W sub 1. So that's equal to C multiplied by the sum vector U sub 1 plus vector V sub 1. And distributing our scalar C through here, we have the scalar multiple C times vector U sub 1 plus the scalar multiple C times vector V sub 1. And again, we'll make a little note to ourselves here that since H and K are subspaces, then we already know by definition that C times vector U sub 1 is in subspace H, and that scalar multiple C times vector V sub 1 is an element of the subspace K. So therefore, our scalar multiple C times vector W sub 1 being equal to C times vector U sub 1 plus C times vector V sub 1 is an element of H plus K, which is what we wanted to show. So we have confirmed our third and final property, and we can say that H plus K is closed under scalar multiplication. And so making our final conclusion here, therefore, since all three properties are met, we are able to officially conclude that H plus K, defined by the set of all vectors W, such that vector W is equal to the sum of vector U plus vector V, where vector U is in subspace H and vector V is in subspace K, is a subspace of vector space V.